Perfect. Okay.
Yes.
Awesome. Okay. So again, thank you guys so much for being here today. As always, I'm extremely excited to share my work with you guys. Now I know that this is, not my first presentation. This is one of, I've done a couple of presentations now with Tropilunch about sacred natural sites and sacred forests, and even Ethiopian Orthodox Tewahido church forests in particular. And what you guys are going to see today is finally some of the quantitative data analysis that I'm doing. And this is going to be for one of my chapters in my dissertation. So without further ado, I just want to provide very, very brief sort of background on sacred natural sites and sacred forests, in case there's a couple among us who are not quite so familiar with them. So sacred natural sites are areas of land or water that have special spiritual significance to people and communities. And now this definition is very broad and sort of not very precise, and that's on purpose because there's just such a wealth of diversity of different types of sacred natural sites, different values associated with sacred natural sites, how people define sacred differs among communities, and they're found all over the world. And so this is on purpose that it's a little bit, the definition is not very precise. Sacred forests, which are a type of sacred natural sites, are usually high values of both biological and cultural diversity. And this is because generally these sacred forests are protected via local taboos or customs and institutions due to their cultural, religious, or ecological values. Now, these are not, these sacred forests are explicitly protected for their conservation value, and that's why they're considered shadow conservation sites. But there's not a precise estimate of how many sacred forests there are across the world, for many reasons, but some estimates put them at about 250,000 sacred forests that range in size from less than a hectare to millions of hectares. So these are really important. They provide a lot of really important ecosystem services, including cultural and religious values. I think something that's also really important to consider when talking about sacred forests is that sacred forests are often conceptualized as these sort of relics of the past, either which are the result of cultural traditions and institutions that are disappearing. But actually, research shows that these are extremely dynamic, complex systems that are often continuously reimagined and reconstructed. And that is very important when thinking about what does those dynamic relationships, what does that mean in terms of the potential for sacred forests to contribute to global conservation goals. Another thing that is really important to consider is that sacred status does not necessarily equal ecological integrity. One of the most sort of iconic ways of examples that I can give of this is the Ganges River in India. The Ganges River is one of the most sacred rivers in Hinduism because it's considered the physical manifestation of the divine goddess Ganga. And actually, very recently, it got legal personhood. So it's very important. It also provides water to about 40% of India's population, but it's also one of the most heavily polluted rivers in the world and often poses some health hazards to its users. So, under which circumstances does sacred status equal ecological integrity? Those questions are important to consider. And when we're thinking about sort of what combination of factors lead to better ecological outcomes, it kind of brings to mind a lot of the research that has already been done on things like, for example, community forest management, work of, for example, Agrawal and Persia that looked at forest livelihoods and local rulemaking and ecological and social outcomes, or Ostram's design principles. And it's also important to consider some of the historic, social, political, and economic context in which these forests are surrounded. But I think also one of the reasons why this is so what this is so interesting as well is because sacred forests have within them sort of already locally adapted institutions in place that manage how these spaces are used. And they also represent a lot of spiritual and cultural values as well. And so this is where Ethiopian Orthodox Tewahido church forests really can be a very useful sort of model network of sacred forests to sort of tease apart some of the complexity and understand some of the social and ecological dynamics in these sacred forests. Very briefly, the EOTC church was established circa 4 AD. It is the most dominant religion in Ethiopia. And there's a very strong connection between the church and forests. Here we have a photo of the stereotypical EOTC church forest, where you have the church in the middle and then it's surrounded by these forests. Now, the sacred status of the forest comes from its function. So within each church, we have a copy of the Tabot, which is a replica of the Ark of the Covenant. And then the forest around this sort of represents a shielding function to the church and the Tabot within. Something that's really that makes this such a good model network is that EOTC forests are sort of example of community-based forest management where local use and decision making is also mediated by the church and the secular government. So it has this sort of hybrid governance system. So at the top, you have the EOTC church is very hierarchical and very well organized. And at the top, you have sort of the Holy Synod and the church structure and the government, which both pass down information about and decisions about the proper use of these forests. In Ethiopia, legally, the government owns all the land. And it wasn't until 2017 that the first policies recognizing the role that communities play in protecting some of the Ethiopian ecosystems came to light. And so at the bottom, so you have local level adherence to rules, maybe some minor differences among rules. And also you have monitoring and punishments for rule breaking. So these forests have a shared sort of top-down governance structure. In our Sadi region, which is in the South Gondar Administrative Zone in northern Ethiopia, so this is an outline of Ethiopia, and this is the South Gondar Administrative Zone. They're also very close together. So we did an analysis we mapped out the Ethiopian Orthodox Church forests in this region, and they're approximately 2 kilometers apart. Yet, despite having all of these things, they have all these things in common, we found that there is significant variation in forest patch dynamics that were not explained by factors, by abiotic factors such as distance to road, distance to market, etc. And sort of some of the variation that I'm talking about is forest size, canopy cover, for example. And this is one of our maps that from a publication that came out this year. It shows 46 church forests where we did some in-depth ecological surveys, and each dot here represents a different forest. And as you can see, each dot also represents different percentages of human disturbance, characterized as trails, clearings, buildings, etc. And as you can see, there is some variation, even when they're fairly close together. So that we wanted to explore more of what are the social variation, the local level variation that affects or drives these sort of ecological variation within these forests. And this is another map of our study region in the South Gondar Administrative Zone. And I think it's really interesting to point out that here, 100% of the forests here belong to EOTC forests. So they're very important for the region. And I like having this sort of a satellite photo to show you guys sort of how they look like in the landscape level. But I also wanted to point out, so each forest is each EOTC forest is highlighted here in yellow. But even just from this photo alone, you can tell, they're fairly close together, but they have differences. There's differences in how they look, in ecological variation among them. So for my research for this particular chapter, I was interested in two research objectives. First, I wanted to identify and quantify some of the social variation among EOTC forest communities. And then I wanted to use those data and analyze the links between some of the social variation and some of the ecological outcomes or variation as well. Now, I used I'm using a social-ecological systems framework to help me analyze this data. So one of the great things about the SES, Ocean's SES framework is that it sort of helps organize things into sort of the resource, some of the ecological system, the social system, and what are some variables that may be important for characterizing these, and then also interactions that lead to ecological and social outcomes. And he also tries to take into consideration other related ecosystems as well as some of the social, economic, and political settings. And this is an example that I took from Dressel et al., which uses some of the same analytical tools that I do. So I wanted to show this particular diagram because here you can really see that there is sort of a lot of different variables that go into characterizing these ecological systems and these social systems. So thinking about these sort of variables, I think about these problems as sort of a multivariate analytical approach to help me really narrow down exactly what are the most important variables in social and ecological, and then try to look at the interactions. And so this is another example for Martin Lopez, 2017. And I want to share this today because oftentimes ecosystem, biophysical variables of ecosystems do not match some of the same spatial, they do not match necessarily the social system in terms of spatial sort of one-on-one. And so in order to deal with these mismatched scale problems, researchers are using some multivariate analytical approaches where you analyze the ecological variables on one side and you analyze the social variables on the other side. You do something like an ordination technique that helps you summarize some of the principal gradients of variation within your systems and condense them, and then you use the outputs from these ordination techniques to do other research. Here they do classification techniques and they look at these systems as socio-ecological units. I don't quite do that, but I wanted to show you this because it's a little bit this analytical process is something that is being used more and more in our field to really look at, because socio-ecological systems are so complex and they have so many different variables working together. And so there are tools out there that can help us identify, explore, and describe some of the patterns in these complex data sets. And that's exactly what I do. So this is sort of my analysis plan. For the social components, I use survey items that then I do an ordination technique on to produce social indexes, which then I use for further statistical analyses. And for my ecological system, I use ecological variables that we gathered on the ecological surveys. And I use the principal components analysis, again, another ordination analysis. These are the same, except that categorical principal component analysis allows for categorical data as well as numerical, whereas principal component analysis is only for numerical. And then I developed an ecological indexes. And I can speak a little bit more about how I do that, but Yes, that's the gist of it. And I just want to say that even though this is a mathematical process, or I use other parts of my surveys for the interpretation of some of these social indexes. I make sure to triangulate my findings using also some of the interviews that I had with people there, literature review, as well as other external data sources to make sure that it's not just, mathematical magic. And then to analyze the links between the ecological and the social dynamics, I use the outputs from these ordination techniques to do further analysis on these. And I also want to say that when I do my quantitative analyses, they all satisfy all the statistical requirements to do so. Okay. So for my survey, so for the categorical PCA ordination analysis for the social component, I use, we conducted 396 community surveys. And again, I use other interviews with church and government officials to sort of give me context and help with the interpretation of these categories that the outputs. And we added some spatial variation here in that we had equal distribution of sites from elevation, montane, and upper montane across 4 woreda, and woreda are kind of like counties. And we had a total of 20 churches. And we also made sure to try to have half and half, male and female. And we initially, when we were making the decisions as to which forest to choose from our 46, we based it on sort of variation in percent human disturbance to make sure that we capture sort of spatial variability, but also some variation in the forest, the ecological dynamics in the forest as well. And this is sort of a map of how that looks like. So we did 4 woredas. This is here montane region, and this is upper montane. And each dot here represents a different church. Right. So I can speak a lot more about what the survey instrument looks like, but broadly speaking, we had our survey instrument, we had 7 different sections. We had responding characteristics like education, sex, etc., age. We used some locally appropriate wealth indicators. We looked at some of the institutional benefits that respondents may get from specifically, we looked at some of the benefits that they may have from the church and some of the benefits that they may have from the government. We looked at some of the benefits that the church provide. For example, holy water is used normally to cure a range of diseases, or whether or not they used some of the wood there to build something. We were interested in also understanding some of the forest perceptions. So for example, one of the questions here asked if denser forests were associated with more, more sacred, if denser forests were associated with more pride for the church. We also looked at some respondent network dynamics within, so how much, for example, how much labor they provided to the church, how much labor they provided to the cabele. And also we looked at some of forest protection dynamics. Here questions were, for example, if what does your church punish for breaking church rules? What are the punishments? Another question is, do any of these stakeholders talk to you about the need to protect the forest? If so, what do they talk to you about and in what frequency? So those were sort of the questions that went into each one. Now for the categorical PCA, I can talk a bit more about how you set up your data before you start doing it. But part of the data analysis prep is that questions that have very low frequency often tend to sort of skew the model. right? And so things like, for example, we found out that almost unanimously, everybody associated denser forests with more prestige and more blessings. And so those sort of items did not go into the categorical PCA because they would have really skewed some the model. And we started our analysis with 48 questions that we coded as 42 different items. And in the end, we ended up with 20 different items. And of these, about 20%, in these, they were grouped in some of respondent level variables, forest protection variables, and some institutional benefits variables. And they ended up falling into 4 different components. And these 4 different components, the variance accounted for is about 48, and I'll talk a little bit more about that later. But component number one, really sort of, there were 2 different sets of variables that fell into this component. The first one is sort of livestock and cooking, and livestock and cooking were not only shows different livelihood strategies here, but also they also talk a little bit more about, or reveal a little bit more about wealth. So here we have that the higher different types of cooking materials, and that for example, gas is far more expensive than using leaves or wood. And then here we have livestock, and we found that livestock is a indicator of wealth in Ethiopia. And then we also had a set of variables that really sort of they're more about sort of interactions between the community members and the Kebele and the church leaders, and about forest protection. So in sites with higher component 1 values, we had higher number of respondents who identified as herders. They were more educated by church leaders about church forest protection. They believed that the church community is responsible for church forest protection. More respondents mentioned that they would inform the head of the priest if they found someone breaking rules. And they also use more expensive forms of cooking, like I said, like gas or electricity. And I can speak a little bit more about these later as well. For component number 2, sites with higher, so here we have 2 sort of sets of variables. The first 2 is agricultural extension, whether they received that as a benefit, and then also whether they had help with land access. And then we also have some respondents' characteristics, like whether they're a farmer or not, whether they had access to land or not, and whether they had in their age. And sites with higher component 2 values had more respondents that received formal help in assessing land access, and subsequently reported more land access. And they also had more farmers. They also had older respondents, and respondents also benefited more from agricultural extension efforts by the Kebele, which is the government. And here we may start to think about the legacy of land tenure in Ethiopia. In Amhara region, land tenure, there was a big shift in that in 2004 that affected how land was distributed among people. And we also start thinking about like the interactions between age and land access. In particular, in order for you to have access with the Kebele, you have to be a Kebele resident. So maybe here we start also to think about and see patterns of migration with age. The third component is a little bit more straightforward and talks a little bit more about education, and two variables still here: educational, receiving education as a benefit, and also individual educational attainment. So these are not like a one-to-one when we look at the relationship between those two variables before we put it in the categorical PCA, they're not like a one-to-one. They're slightly different. So for educational benefit, usually people discussed that they received help for their children or even their grandchildren to get education, whereas individual educational attainment is whether they had an education themselves. For a lot of the older respondents, we often have, there's a legacy there of some of the educational policies from the last regime that they often talked about. And then finally, the last components, we consider this more of like a forest protection. And the variables that fill in here are whether a person said that they did not observe people cutting wood within the site, they did not see people picking up firewood, and they did not see people allowing their cattle within their sites. And these are all forest protection rules. And the reason why it's lack of is because we wanted them to be positive. So the higher values means that in theory that these sites have less of these events occurring. And so I'm going to talk about these as the social component one. Initially, when trying to sort of summarize what this component was, I used words such as, for example, social capital, but I'm still working on how to succinctly describe what's happening here. Component number 2 is land access and agricultural extension. Component number 3 mostly reflects education, and component number 4 mostly reflects aspects of forest protection. And then I used the outputs from these models and I added them to look at the variation among different scales, specifically among sites, among Woreda, and then across elevations. And what I found was that there was significant variation of these social components across sites. And here I did some, these are some rough maps of my study sites, and the colors represent different values in each dimension. So again, I just want to remind everybody that the higher the values, the lighter the color, the better they do in that, the more they have of that dimension. And so we did not necessarily find any patterns in terms of which sites always had the lowest numbers across these. But here you can see, for example, that sites 7 and 27, which is kind of hard to see because they're so dark, almost, they almost always have the lowest values in this. So here again, this is the social component number 1 that looks at wealth, livestock, and responsibility for whose responsibility it is to protect the forest. Here we have dimension number 2 is land access and agricultural extension. Dimension 3 here looks at education, and 4 is forest protection. And then, so just looking at these in this way, you can start seeing some maybe spatial patterns. And this is when you add up to the Woreda level. And then you can really start to see that some of these social, and we also found, by the way, significant variation across all of these social components at the Woreda level. And when we did a post hoc test, the only one that did not have, that did not tease out some of this variation was at the Woreda level in a student post hoc test was this agricultural land access and agricultural extension. And this is a more conservative test. I also think it's really interesting to look at the variation among the social indexes or components. And so this is a very busy plot, but this is an ordination plot with mean categorical for all our sites, which each dot represents a different respondent. And in the middle, you have the mean per Woreda. And then the ellipses are 95% T distribution. And what you can see is that, so this variability gives us insights into how similar respondents are per site and per vereda. And you can see here, for example, that in a CITE, for component 1, which is some of the social components, you really don't have, you have a lot more variation for this social component than in the component number 2, which is land access and agricultural extension. So people's responses were far more consistent in the CITE when it comes to land access and agricultural extension efforts, indicating that these efforts are more equally distributed in this vereda than some of these perceptions about whose responsibility it is to take care of the forest, and also some and wealth factors. And I'm, for the sake of time from this. And so now comes for the ecological side of my model. So for the ecological variables, we have 14 ecological variables that went into the model, and these ones were at the site level. So for our surveys, it was the model was done on people with an N of 396, and then this one is for an N of 20. And these and so some of the variables are forest size, elevation, biomass, abundance, reprised species richness, etc. And these broadly fell into 3 components. Component number 1, the variables there are associated with sort of forest health and disturbance. So we have forest size, biomass, reprised species richness, and biodiversity with a negative relationship with disturbance. So we have forests that are bigger, have more biomass, more species richness, more biodiversity, but they're also, and there's a negative relationship with those within that component with disturbance. So the higher the value, the better forest health there is. And for component 2, we mostly have associations with forest health. So higher carbon concentrations, higher nitrogen concentration, and negative relationship with bulk density. And bulk density is an indicator of soil compaction. So yeah. And then the last one is mostly phosphorus. And the relationship between the 2 variables that fell there, which is nitrogen and phosphorus, and total P, is mostly a relationship of the mathematical relationship of how these values are produced. Right. So then the next step was looking at the links between some of the social variables and indexes that we created and the ecological indices that we created. And just a reminder, there are the 3, and so there are the 3 ecological indices of forest health, soil health, and phosphorus. And to do this, I use 2 different analytical methods. First is I did global models that looked at the relationship for each that used all of the social indexes as predictor variables for each ecological index, and then based on what of whether or not the model recognized any significant social indexes, I then did more analysis to understand the relationship of the ecological and the social indexes. So for the first one, forest health, we found that the social component 1 that had those variables of wealth and interactions between the community and the church and the government officials was significantly associated with forest health, as was land access and agricultural extension, and also forest health. Now, we found that the forest health and social component 1 in land access and agricultural extension both have positive relationships with forest health. So, for example, the higher the land access and the agricultural benefits that respondents reported, the healthier the forest was. Surprisingly, we did not find there was a significant association between forest health and forest protection. So if you remember, the forest protection index was about where people reported whether or not they had seen those rules being broken. And so we would imagine that if people say that they have not seen these rules being broken, that might mean that it's more healthier forests with less disturbance. But we actually did not find that. And I think that's really interesting because it really shows that perhaps maybe social desirability bias when it came to people answering those questions. For soil health, which is the index, the ecological index 2, the global model, we found that land access and agricultural benefits, that index is really important for predicting soil health. But surprisingly, we found that the relationship is negative. So soil health decreases in areas that have more land access and agricultural extension. And we did not find any relationships with phosphorus. The only one that came out in the global model was the education component, but that's mostly driven by the elevational relationship. They both vary by elevation, and so it's not a causal relationship there. So that was a lot, and you guys are the first group of people that I do this presentation for, and so. So I think for the next steps and considerations is on trying to understand exactly what my analyses, how they can be used to inform policies in the region. But also I want to look at, I think that there's still more analysis to be done in order to really understand the ecological and social relationships in this context. For example, I think that I can use other methods of spatial clustering rather than say lump everyone by Woreda or elevation. I would like to use other characteristics to lump people together and see if the relationship, and see what relationship dynamics, if they change some of the dynamics that I observe. I also want to say that this has been a very quantitative, this is a quantitative chapter, 100%. But other parts of my dissertation are going to look at things, the variables, the characteristics that did not really show a lot of variation. For example, again, going back to, most people said that dense forests bring more prestige and they bring more luck. So I also want to really explore more in depth some of the similarities among sites, not just the differences. And I think that using, so there's a lot of diversity across sacred natural sites and sacred forests, but I think that these analytical methods really have can be a new ways of rapidly assessing some of the most rapidly assessing where the variation lies that can explain some of the ecological variation in the system, and that can inform policy a lot more. Yeah, and a lot of information I just threw at you guys. So that I am open to questions and comments, and yeah.